All right, so now that we know how to find derivatives, we want to take the next step. And the next step is actually using it. Okay? Now this is something we've alluded to a couple of times now, where once we know the derivative, actually finding what the rate of change is at a point. So we've looked at a couple examples where we kind of did this just in passing, but I want to look at it more specifically now. Okay? We did this example actually yesterday, except we left off the second half. Find the rate of change at x equals 4. Okay. So we did this, and we found out that that dy dx, which is the same thing as f prime of x, remember the notation is the same idea, okay, equaled 2x plus 3. All right, that's what we found as our answer yesterday. So if I want the rate of change at x equals 4, one way of expressing this would be saying we want to find f prime of 4. Whoop, not of x. F prime of 4. Okay? In other words, we want to find f prime of x and then plug in 4. All right? So, since we know f prime of x is 2x plus 3, we're going to take that 4 and plug it in for the x. And we now get 8 plus 3, which is 11. Okay? Now, let's revisit the function that we were looking at when we introduced this exploration. We had our phone falling out of our pocket, and we wanted to figure out how fast is this thing going when it's a foot off the ground. Okay? So that function was its distance off of the ground equaled 40 minus 16t squared, because it was falling from 40 feet up, right? Well, let's figure out what d prime of t would be. Okay, so we're going to get the limit as h approaches 0 of f of t plus h minus f of t all over h. Or actually, I shouldn't be using f's, I should be using d's, because this is the function d of t. Alright, so d of t plus h minus d of t. There we go. Okay, so now it's the limit as h approaches 0 of d of t plus h is going to be 40 minus 16 times t plus h squared. Okay? And then we're going to subtract the original function, the 40 minus 16t squared. Okay? That's all over h. Alright, so we've got to FOIL this and then distribute the negative 16. So I'm going to do that all in one step. You guys know how to FOIL and distribute, so you can figure that out. Alright, so we have a 40 minus 16t squared minus 32th minus 16h squared minus 40 plus 16t squared. Alright, so that's the numerator FOILed out, and we distributed the negative and everything. And now what happens?
Negative 32t.
I'm sorry, what?
Negative 32t.
Oh, when you completely simplify, yes. Alright. Notice here the 40s cancel out, the 16t's cancel out to 0. The only things left have h's in them, so I can cancel out the h's. Alright, now I only cancel out one of these two. But notice now I have something where I can take the limit as h approaches 0. It's a negative 32t minus 16h. Okay? And now I have something that I can just plug in the 0 for h, and I get d prime of t equal to a negative 32t. So guess what? How fast was our phone falling when it was a foot off the ground? What would I be finding? Remember that point was at 1.561, right? Or to be exact, it was the square root of 39 over 4. So what am I going to do with my derivative now?
D prime of negative root 39 over 4 equals negative 32 times root 39 over 4.
Very good. Okay. So negative 8 root 39. Okay. And this was in feet per second. And we could find that as a decimal, can't we? Can someone use their calculator here? What's negative 8 times root 39?
Negative 49.92.
Okay. And if you remember, back when we did this exploration, those, as we brought the point closer and closer, our last couple ones were like 44 point something, 47 point something, okay? Can't remember exactly what they were, okay? We got a negative 50 at one point, okay? So, and I think that it shouldn't ever go above it, but I think that's partly because we rounded it to the 1.56 when we were doing the exploration, all right? But this is the exact speed that it's going as it's falling towards the ground. And then if we wanted to see it when it actually hit the ground, okay, we would have to figure out what the point was on the original function when the height was 0. So this would have hit the ground when 40 minus 16t squared equaled 0. So that would be t squared equals 40 over 16, which would be 2 root 10 over 4, or just 10, root 10 over 2. Okay, so then we could actually see what speed it's going to go when it's actually hitting the ground by doing d prime of root 10 over 2. Okay, and that's going to be negative 32 times root 10 over 2, which is a negative 16 times root 10. And what do we get for that?
Negative 50.60.
Okay, great. Alright, and then if you wanted, you could get into some physics and figure out what's the mass of your phone, and then you could figure out with what force it's hitting the ground, and then we could determine if it's actually going to survive the fall or not. My guess is no. Alright, unless you have a really good case on it. Okay? So, that's our application. That's one application. And guys, the thing is, we're talking about movement, but the reality is you can use this with any function. Let's say we have an exponential growth function for a population of a city. If we've projected it out, we could then also look at, okay, 3 years down the line, exactly what rate of growth do we have here. Okay? So, all right, I'm going to change things up a little bit from what's on the Sunday Post. We're going to take some time and we're actually going to work through these in groups tomorrow. Okay? So I was going to do some of this in class today, but we're not going to do that. We're going to do this in class tomorrow. We're going to do another day of limits on Monday to wrap everything up. Okay? So.